All right, good morning, everyone. It is 10 a.m. Eastern Time. Welcome to the September U.S. grain weather webinar. We will, as usual, wait just a couple of minutes to get as many people as possible on board, and then we'll start with the discussion. All right, it is 10:02, and we will go ahead and get started. Welcome again, everyone, to the September U.S. grain weather webinar. This is the fourth webinar we've done this summer. We've enjoyed doing it. And as always, we hope that the folks that are attending get some value from the information that we are providing in your grain trading activities. One note is that we recorded our last forecast of the forecast video on September 2nd. So if you're new to this series, we use the ECMWF extended runs on Fridays to look at what the ECMWF IFS or the ECMWF medium range forecast might look like when you show up in the office on Monday morning in terms of the 1 week and the 2 week temperature forecasts. There were a few weeks where it was remarkable how well the outlook did, and most weeks, at least we think there was certainly some useful information. So hopefully you got a chance to see some of those. We'll certainly be doing it again next year. And again, we're hoping that you got some value from it. One question to ask is, did anyone watch them? So we were posting them on YouTube on Friday mornings and Monday mornings. We were putting them out on socials. And it ended up being that we had just over 900 views accumulated over the summer for these views. The slope of the line shows basically how many views there were increase from the week before. So it's no surprise that the most watched series was in early July, when the corn crop and the soybean crop are going to be most sensitive to weather conditions. So we're certainly happy with that result. And it was a great, let's say, extension of a unique capability that we're able to offer customers and market participants. So we will follow the same format that we followed in the other three. We're going to start off by talking about October and September precipitation. So first off, let's take a look at July, or remind ourselves of what July 2025 looked like. So in July this summer, there was a lot of precipitation. So corn was 159% of normal. Soybeans was 148% of normal on a crop production weighted basis. Just about everywhere in the corn belt and the soybean belt was wetter than normal in the month of July. And then we had a flip of the pattern, and the eastern and southern portions of the corn belt turned sort of dramatically dry. I saw that Ohio was the driest on record in 135 years, and we will also show as the driest on record in 45 years. So the corn production weighted precipitation was 88% of normal, and the soybean crop production weighted precipitation was 78% of normal in August. And then to place this into context, we show the historical ranking from 1981. So Ohio at 44 means that on a corn production weighted basis, there was 1 year that was drier since 1981. So the 44, the 43, the 40, and the 44 are all in the 5 driest years on record. And then we see the opposite, basically in the Western Corn Belt that had a relatively wet August And in particular, South Dakota, we see was one of the five wettest records, wettest Augusts on record. And so there was a very strong dichotomy in precipitation, essentially dry in the east and plenty of moisture in the west, yeah, for the month of August. And then if we look at September to date, we see the dry conditions have sort of expanded, where a little bit of rain in the Tennessee Valley, but certainly very dry conditions across the core elements of the Corn Belt. And in fact, the corn production weighted precipitation is only 56% of normal. So far in September, the US corn crop on average has received only 56% of normal here in the first 10 days of the month. And the soybeans is not far behind at 58% of normal. And to put that into context, we combined August and September month to date. And again, so we see the Eastern Corn Belt ranks very, very dry, whereas the Western Corn Belt ranks not record wet, but certainly above the median in terms of wetness conditions since 1981. All that being said, if we look at corn over the prior 90 days, the corn production weighted precipitation is still above normal. And so we see in this bottom row here, we see well above normal precipitation occurring periodically through until really mid-August. And then we see this dry conditions set in where when it rained, again, when it rained across the corn areas on average, it was below normal. And again, I could show the soybean chart, but it's so similar that it essentially looks like this. In fact, sorry, here it is. I forgot I added that in. But so soybeans looks very similar. So, lots of people are comparing this year to last year. We had a relatively wet July last year, so 124% of normal versus 158% of normal this year. And we wanted to take a deeper look at how similar the precipitation this year is to last year. And so to do that, we created a chart that shows the rolling US corn production weighted 30-day total precipitation. So the y-axis is in inches. So that is 30-day accumulated precipitation over the prior 30 days for any given date. The blue line is last year. The red line is this year. And then we added on the ECMWF forecast. And so it is true that, after, say, August 1, there were drying conditions, but we think this is a pretty dramatic difference. So if we look at the date of maximum precipitation from 2024, it happened right around what was probably the silking period for the US corn crop in 2024. And then the dry conditions set in, and there was a relatively gradual decline of 30-day accumulated precipitation into September 1st. This year, however, we see that the rains lasted 3 to 3.5 weeks longer before there was a dramatic dry condition set in. So we think that comparisons to 2024 certainly have to be taken with a grain of salt because the precipitation hung around, let's say, a lot longer in 2025, and that is going to make a difference to the end of season yields. Turning to temperatures, again, when we did this webinar in mid-August, the conditions were headed towards cooler than normal conditions. The month ended and temperatures were generally cooler than normal. So we see corn and soybeans are either just above or just below normal. And so generally cool in the Eastern Corn Belt and near normal conditions to slightly warmer conditions in the Western and Northern corn and soybean growing regions. In terms of the rankings, it is generally, we're looking at maximum temperatures here. And so the numbers that are in the 20s and 30s will be below the median, so it's relatively low maximum temperatures in terms of their rankings as well. In terms of September month to date temperatures, we have a rather remarkable map here. So conditions are basically 8 degrees below normal for the corn and soybean crop in the United States. The core of the cold conditions were basically focused on Chicago and counties in northern Illinois and southern Wisconsin and eastern Iowa. And so this is sort of a remarkable turn of events in terms of the weather conditions. And we think it plays a role in the interpretation of the yield forecast as well. And I will talk about that in a little bit. Um, so if we look at temperatures that occurred um, over the last 90 days, we're going to focus on Illinois, Indiana, and Ohio here as the regions that were turning dry. Um, the thing that we think is most interesting is the temperatures turn dramatically colder than normal. So in earlier webinars, I talked about the gray band here being the 90th percentile of observations. And so in this case, I've also commented that if the observation drops outside of that envelope, that we can consider it to be an extreme event. And so we see here extreme cold temperatures in each of the states that I've mentioned. Note that this date essentially lines up with when the truly dry conditions started. And so one of the reasons we think the dry conditions are not as bad or impactful as they could have been is because of these colder than normal temperatures. So these colder than normal temperatures are lowering evapotranspiration in the crop. And although the dry conditions are certainly not supportive of yield, they're also not disastrous in terms of yield declines because of the relatively low temperatures that occurred across the Corn Belt. Last weekend, there was a freeze event. So this map looks awfully similar to the one I just showed with minimum temperatures. But in this case, this is really just the 3 days ending the prior weekend. So this covers Saturday and Sunday. And notice that the deep blue of -10 to -20 degrees temperature is much larger. And so one of the questions certainly to ask is whether or not the corn crop was negatively impacted by this freeze event. And so I'll just highlight here, we have North Dakota corn production weighted minimum temperatures. And so the freeze event is this minimum temperature here of that shows 36 degrees. So I do want to highlight that the data we're using is it's county averaged data. And then to create this graphic, we're averaging over all counties that grow corn based on their relative production for the state of North Dakota. The point is that the extreme values of, say, 32 degrees or 30 or maybe a 28 isn't, it's captured in the data, but it's smoothed out because we're doing county level averages. So our rule of thumb is when the county level temperatures reach around 36, 35, 34 degrees, there is certainly a risk that there is some localized freezing. If it reaches 32 or 30, there certainly is freezing occurring within a given county. And so we did an analysis here in which we looked at the minimum temperatures. So this is the minimum temperature from August 1st to September 29th for each county. And then we calculated how much production may have been affected. So based on the event last weekend, there were a few counties where the temperatures were below 34 degrees in our county level data set. And as we see for both corn, possibly 93 million bushels were affected. And for soybeans, possibly 32 million bushels were affected. So this is a very minor event in terms of the risk of freeze occurring, the risk of freeze damaging either the corn or the soybean crops. One of the reasons that we were watching this is because we are working on an experimental product of using the ensemble data from the ECMWF and the GEFS models to try to understand the risk of a freeze event. And so this is just an example map showing the probability on this map. This is the probability of 34 degrees or lower occurring based on and analyzing the county level forecast for the ensemble. The right-hand map is the probability of 32 degrees or less occurring based on processing the ensemble data as well. And so, you know, there was a risk and that risk actually occurred in this case. So this was, say, a 60 to 80% chance of 34 degrees or lower. So this is something that we are evaluating and seeing if it makes sense to add to the product. There's been a lot of discussion around corn disease pressure, and so I thought we should probably at least comment on that in this discussion. So we found data from the Crop Protection Network. The Crop Protection Network is basically a series of land grant institutions across the Midwest United States that pool resources together to try to identify risk to the major crops in the United States. There is data available from 2012 on. And as I have highlighted here in the quote, there's no consistent method for trying to estimate how much crop may have been damaged by given diseases or insects. And the source of information comes from a wide range of potential sources, but it is the only consistent historical source of information that I could find on crop loss due to disease. And so we plotted the percent of normal precipitation on a corn production weighted basis for the major corn producing states. And in this case, July is being used as a proxy for a bunch of days that are centered on the silking date, the 50% silking date for each state. So we could have been more specific, but we thought this was a reasonable first analysis. And what we see is for southern corn rust, there certainly seems to be, at least in 4 out of 5 states, there is a signal of the emergence of southern corn rust when precipitation is greater than normal in the month of July. And for tar spot corn, the signal is nowhere near as strong, although, again, we see ranges from 80% to 120% the emergence of tar spot corn. So we would, this is a very light indication that there's a weather sensitivity to these diseases, or that the corn is more susceptible during certain weather conditions. Much more work is required to be able to quantify this. What I think is important here is the y-axis. So this is the percent of annual production lost based on that state's total production for any given year. And so we are in single-digit percentages on individual states. And so while certainly a 4% loss in the state of Iowa is certainly significant for the state of Iowa, if we expand out to the national case, the actual impacts start to reduce down. So that's not to say there aren't corn diseases and there isn't going to be corn loss due to the diseases, but I think in the context of national production, the impacts will be relatively minor. So we talked about silking dates, and so we produced this map, which shows the date that each state reached their 50% silking date in 2024. So a lot of them reached their 50% silking value sometime in the month of July. And then underneath that, we have how many days from that silking date we are today. And so we are essentially between 50 and 60 days from the silking date. The reason we produce this map is we end up getting an emailed question to us that asked the question, how does weather after silking impact end of season yields? And it's something we hadn't taken a look at. And so we worked up an analysis of that. And so I want to highlight here the number of days since silking, because we're going to ask the question, how does post-silking weather conditions affect corn yield in this case? And so I've got Iowa on the left, Illinois on the right. We have average maximum temperature on the left-hand column, average minimum temperature in the center, and average precipitation as a percent of normal in the right-hand column. And then we have a 15-day window after silking, a 30-day window, a 45-day window, and a 60-day window. So as of today, we're somewhere in this 45 to 60-day window. And the purple line shows either the value for this year or the window to date value for this year. So we're looking at Iowa and Illinois, the 2 major producing corn states. And there are certainly things like minimum temperature values that put corn yield in a negative territory. But the other 2 variables tend not to be in significantly below trend corn yields, whether we're looking at Iowa or whether we are looking at Illinois. And in fact, we see, for example, in this 45-day window, precipitation is actually suggesting above normal corn yields. So in general, our experience uh, based on the analysis we've done this year and in past years. Maximum temperature and precipitation are substantial drivers of yield. There's many variables that might contribute to yield. And that's not to say that the minimum temperature is not an important driver, but my sense is it's not as strong a driver of maximum temperature and the average precipitation. So if we had all purple lines in negative territory, I'd be confident of below trend yields, but we don't have that situation. What we have is the purple lines are either uh, they're somewhere between above normal to below normal yields. And so we think that the dry conditions that are occurring and the delay and the decline in the precipitation that I showed earlier is a pretty significant factor in maintaining above normal yields that the CropProphet model has emerged with so far this year. We also we looked at Indiana and Nebraska, and I'll just quickly say that the picture is roughly the same. So in terms of state crop condition reports, the charts here or the maps here show the change over 2 weeks of the crop condition reports. And so we see dramatic changes in the east, which should come as no surprise given the onset of dry conditions. The national level has declined by 10 good to excellent points. And the result then is in terms of the historical comparisons that we've been looking at all year, the Eastern Corn Belt has degraded to the point where its percentile in the distribution of historical condition rankings is now relatively low, not the lowest ever seen, but certainly low for the year. Whereas essentially west of the Mississippi, the corn yield condition, the corn condition and the soybean condition have remained quite high on a relative basis to prior years. One comment, we're going to start looking at some of the impacts on the crop yield forecast models that we prepare. And I've said to, we talk about the fact that our corn yield forecast model is the combination of a county level weather driven model and a state level crop condition based model. And as we go through the season, the weather model gets a stronger and stronger weight in our overall prediction, meaning that the reverse is true, that the state level crop condition reports become less and less important as we go through the year, through the crop season. So these changes by no means are not insignificant in our overall crop model. They become less significant as we go later into the crop season. And so if we look at the change in the CropProphet corn and soybean yield models over 2 weeks and over 4 weeks, we see in particular in the 4-week time period, we see the Eastern Corn Belt yields have been declining in many of the states, as well as also in the 2-week time change as well. In the 2-week change where we see, for example, Indiana or Michigan with an increase in the yield, we attribute this actually to the cooler than normal temperatures. So the heat risk has been removed. Evapotranspiration is relatively low. And so during this period, the crop was given a chance to potentially increase yield relative to prior values as well. And the same is true across corn and soybean crops. So if we look at the 4-week change, the maps look very similar. One of the things that is interesting to note, however, is that in the national change values, we see declines in the Eastern Corn Belt and the southern portion of the Corn Belt and the soybean belt being offset by gains in the Western Corn Belt. So the precipitation in the Western and Northern Corn Belts are helping to maintain or even increase the yields in our yield forecast. And those gains are offset by the declines. And the net then is a national change that is essentially zero. So let's take a look at the weather forecast. So we are looking at the ECMWF forecast for temperature and precipitation. We see in the 1 to 7 day time frame here in the upper left corner, dry conditions prevail across almost all of the Corn Belt. And then as we shift into the 8 to 14 day forecast, we see that, again, the pattern that has emerged remains that the Western and Northern Corn Belt are forecast to receive precipitation. The Eastern and Southern Corn Belt remain relatively dry. And then likewise, we see heat emerge. So high temperatures well above normal in the 1 to 7 day time frame. and then not quite as strong, but still remaining in the 8 to 14 day time frame as well. And then if we look at the impact that the weather forecast has on the yield forecast, the pattern should not be a surprise. The eastern soybean region and the eastern corn region are seeing yield declines. That is due to the heat and the dryness. In the areas where rain is forecast sees the potential for yield increases as well. And again, we see offsetting changes such that the national change is relatively small. So in the August webinar, I showed this chart and I highlighted the fact that the prior 4 Septembers have been drier than normal. And certainly it looks like when I produce this chart in next August's webinar, we'll be able to say the last 4 years have been drier than normal in September. And again, we believe this is driven by the large scale teleconnections. But it certainly is interesting that this trend seems to be continuing. I also happened to show this forecast in which we looked at an analog of the Pacific Decadal Oscillation. So the Pacific Decadal Oscillation is a pattern of sea surface temperatures in the northern Pacific Ocean. And we took a look at the chance of a light, weak La Nina occurring during September and October, and we drew up an analog showing dry conditions across an awful lot of the Corn Belt. So this analog hasn't quite turned out in that it's certainly dry in the east. The western component is turning out to be wetter than normal, but that is the nature of these analogs. Every year that we sample to create the analog is different, and we're trying to assess, the overall likelihood of different conditions occurring. But certainly the dry signal being driven by large-scale climate indices seems to be occurring this year. And so to do a long lead forecast, I'm going to take it in a slightly different direction. So I showed this chart in June, in which we've examined the relationship between the corn and soybean crop progress with weather data. And so in this case, we're looking at the number of days between the 25th percentile and the 75th percentile progress for each of the stages. And if we draw our attention to the percent harvested, we see, and it comes as no surprise, that on a US basis, and the point is, I will say this chart looks exactly the same whether you do states or whether you look at the United States overall. Very dry conditions result in very fast harvests, and very wet conditions result in very slow harvests. And so the long range outlook is going to be that in the Eastern Corn Belt, harvest is going to happen very quickly, because at least now it's likely to remain dry, and that we're just about to start harvesting here pretty soon. And in the Western Corn Belt, assuming that the precipitation continues, the harvest is going to take substantially longer, meaning that the freeze risk in the Eastern Corn Belt is probably ameliorated because of the relatively rapid harvest that is going to ensue, whereas in the Western and in particular the northern areas, the freeze risk certainly remains because harvest likely will take longer. That is all we've got for today. Thanks everyone for attending. There is a Q&A, and I'm happy to entertain questions. Let's see. I see a question about how much sun did the crop receive during August. So I don't have a slide prepared on that, but let me take a quick look at CropProphet if I can figure out how to do that. Oh, I know what the problem is. Sorry, I'm running into a problem. So we know who asked the question. We'll make sure that we send you an email with the answer. So I don't know the answer off the top of my head, unfortunately. I see Christian answered. All right, thank you, Christian. So we had a question about soybean frost damage in the Dakotas. So I did cover that. Again, feel free to email us to get some additional information. Yeah, so we were just asked about the change in the crop report on Friday. Yeah, so our thinking is there's certainly a chance of a slight decline given the weather conditions, but probably nothing dramatic. Let's see, there is a question. There is a question about analogs for North Dakota, South Dakota, and Minnesota warm conditions. So I'm not exactly sure what the question is. So I will say in general for anyone attending, if you want to email your question to info@prescientweather.com, we'll do our best to answer it. So just to be transparent, I'm not exactly sure what the question is in terms of the analogs, but we're certainly happy to answer that offline. We have another question if we can calculate the loss in the crop from diseases um, and from attack of locust or grasshoppers. So in terms of the crop loss from diseases, I don't think we have enough data really to be able to confidently and quantitatively calculate the potential disease loss. I think the information that I provided was designed to sort of give us the order of magnitude. So small single-digit percentages in some of the key growing states are possible, and but whether it's more widespread or potentially more significant than that, I think is really hard to quantify given the data that is available. Um, Again, thanks everyone for attending. I'll just highlight this is the fourth one of these. So we did a June, July, August, September. I hope that these were useful to everyone. Feel free to give us feedback at info@prescientweather.com. You might also be able to give us feedback because my colleague Christian is going to be sending out a survey about the survey about this webinar, and feel free to fill it out. Thanks everyone, and good luck finishing out your grain trading season, and then good luck starting when South America weather starts to impact over our winter. Talk to you soon.